All right, functional groups, making esters. This is going to be the transition between just talking about some functional groups that can go into hydrocarbons to start talking about the reactions that can happen when we have hydrocarbons. So esters are really cool compounds. We'll talk about why they're cool in a bit. So listen up, but we're going to talk about how we actually make these things. We're going to take, first of all, what are esters? Okay, so an ester is created in a reaction between an alcohol and a carboxylic acid. The reaction is called an esterification reaction, and it's a type of condensation reaction. And why that is because the word condensation refers to the fact that we got water as a product. So the reaction summary is here. We take an alcohol, any alcohol, react it with a carboxylic acid. We need some in experimental conditions. Usually it's heat and an acid as a catalyst. But what we're going to make is an ester and water. So we're going to combine these alcohols and carboxylic acids together. We're going to make water by itself and the ester as well. So let's just dive right into it. So here's an example. I've color-coded all of this for you. So here is, again, my alcohol, 2-butanol, reacting with a carboxylic acid, ethanoic acid, aka vinegar. And what we get is 2-butyl ethanoate plus water. Again, saying this ester is kind of a mouthful, but here's the reaction and how it happens. 2-butanol. Again, but means 4, and we've got the alcohol group on the second carbon. Again, all single bonds for the and we've got this OH alcohol group there. The hydroxyl group is there. Ethanoic acid. Again, carboxylic acid group. Ether, F means 2 carbons and single bonds. So there's the single bond. Here's my carboxylic acid group. What happens is we combine these 2 OHs. So this OH and these OHs combine. Now, what we do is we take one of the OHs and the H, and we end up with the ester. And here is what it looks like. So here is the vinegar part here, the carboxylic acid. And you can always tell the carboxylic acid part because of the carbon to oxygen double bond. It is reacted with an oxygen. That could be this oxygen here. And then we get the 2-butanol, the alcohol part here. So what we've done is we've taken this OH group and this H here and made them connect together to make the water. So H2O is the water that gets created. So there it is there. So again, always an alcohol plus a carboxylic acid. So naming esters is pretty straightforward if you remember where to start with. So the name of esters comes from combining the alcohol name with the carboxylic acid name. And then the ending of the acid changes from the anoic acid to anoate. Okay? So here's an example. If I took methanol and butanoic acid to react together in the esterification reaction, what is going to be the name of the ester that's produced? Well, meth is the alcohol, methanol. So we start with that. So it's methyl butanoate. And this actually has a kind of pineapple-y tropical smell. So all you have to remember is name the alcohols first and the carboxylic acid second. Alcohols start with the letter A. That's at the beginning of the alphabet. So always start with the alcohols first. Okay? So properties and uses of esters. These are smells. The smells in our world, a lot of them come from esters. So esters can be naturally, they naturally occur, or they can be synthesized or made in a lab via esterification. And here is a chart. This table has got all these, here's all these alcohols, and here's all these different carboxylic acids, and you can see all the different types of smells that we can create, right? So we can take that methyl group and react it with butanoate, and we end up with kind of a pineapple-y kind of smell. We can make banana smell. We can have different kind of tropical leaves or tropical fruits. We can have flower, floral. We can have a woody type smell, mushroom type smell, more alcohol-based smell, coconut smell. It's all kind of crazy what we can get from it. So it's kind of interesting what we can do. So again, esters are responsible for many of the odors of fruits and flowers that we smell out in the world. And synthesized esters are used and they're added in processed foods, perfumes, and other cosmetics. So if you ever put on any cologne or anything like that, these are all synthetic esters that have been made in a lab. So in this note, we just talked about the properties, uses, naming, and how to actually make esters by combining alcohols and carboxylic acids. That's our chat. Thanks.